So let's simplify this to a single trigonometric ratio for 6 marks. So we have sine 3x plus sine x, all of that is divided by cos 2x plus 1. So the first step is, let's try to deal with the sine 3x. Okay, so we're going to change it to a compound angle. It's going to be sine 2x plus x, okay, plus sine x. And then all of that is divided by cos 2x. So let's leave that for later. So cos 2x plus 1. And then the sine 2x plus x, when you expand it into its identity, it's going to be sine 2x cos x plus cos 2x sine x. And then plus sine x. All of that is divided by, let's change this cos 2x to cos squared x minus sine squared x. So this cos 2x has an identity which says cos squared x minus sine squared x. And then this positive one has an identity of cos squared x plus sine squared x. Okay, let's do the numerator from here. Sine 2x, when you expand that, it becomes 2 sine x cos x times this cos x plus this cos 2x. Let's change it to its identity that has sine. The reason why we're changing it to sine is because the numerator mostly has sine on it, so most likely we're going to use that identity, which says 1 minus 2 sine squared x times sine x plus sine x, and then divide all of that. Cos squared x plus cos squared, that is 2 cos squared x minus sine squared x plus sine squared x. Going to cancel each other out, so we're going to be left with 2 cos squared x. Now 2 sine x cos x times cos x, that is 2 sine x cos x times cos x, that is cos squared x plus sine x times 1, that is sine x. And then sine x times negative 2 sine squared x, that is negative 2 sine cubed x plus sine x. Divide all of that by 2 cos squared x. And then from here, let's change this cos squared x to its identity. So 2 sine x times 1 minus sine squared x plus sine x plus sine x, that is 2 sine x, and then minus 2 sine cubed x. Divide all of that by 2 cos squared x. 2 sine x times 1, that is 2 sine x minus 2 sine x times negative sine squared x, that is negative 2 sine cubed x plus 2 sine x minus 2 sine cubed x. Divide all of that by 2 cos squared x. And then from here, 2 sine x plus 2 sine x, that is 4 sine x, negative 2 sine cubed x minus 2 sine cubed x, that is negative 4 sine cubed x. Divide all of that by 2 cos squared x. We have 4 sine x minus 4 sine cubed x, all of that divided by 2 cos squared x. From here on the numerator, you can see that we have a common factor of 4 sine x. 4 sine x divided by 4 sine x, that is 1. And then minus 4 sine cubed x divided by 4 sine x, that is negative sine squared x. Divide all of that by 2 cos squared x. This 4 sine x will remain the same. This is an identity, which is the same as cos squared x. Divide all of that by 2 cos squared x. Now cos squared x divided by cos squared x, that will cancel each other out. 4 divided by 2, that is 2. Sine x divided by 1, that is sine x. So the final answer is 2 sine x. We have simplified to a single trigonometric ratio. So this question is basically a trig function, okay? So it says in the diagram, the graphs of f of x is equal to 2 sine 2x and g of x is equal to negative cos of x plus 45 degrees are drawn for the interval x is in elements of 0 degrees and 180 degrees. A is a point 105 degrees and negative 1 lies on f. Okay, so we have f and then we have g. Okay, we have our y-axis, we have our x-axis, and then we have our a, which is shown on the information. It's also shown on the diagram. So the first question for 1 mark says, write down the period of f. So basically, what is the period? This is the key word. The period is basically, the number of degrees it takes the function to repeat itself. So you can see in this function f, because they're asking for the period of f goes up and then it goes down, then it stops here. And then the cycle repeats itself again. So it takes 180 degrees for the function to repeat itself. So the answer is 180 degrees. So now for 2 marks, we're asked to determine the range of g in the interval x is in elements of 0 degrees and 180 degrees. So which graph is g? It's this one over here. So it's the function which says y is equal to negative cos of x plus 45 degrees. So the range is basically the set of all y values in that particular function, okay? So this function starts here at this particular point and the highest point is up here, okay? So it's at positive 1. Alright, now how can we find this value over here? Now you can see that this value is not at negative 1 over here, so we need to find the value of y here. Now we know that on the y-axis, x is always equal to 0, so let's just simply substitute x. So y is equal to negative cos of 0 plus 45 degrees. Y is equal to negative cos 45 degrees. And then finally, y is equal to negative, when you punch this into the calculator, you're going to get negative root 2 over 2. So this is the lowest point on the function g in this interval from 0 to 180. And the highest point is at positive 1, so it's going to be y is in elements of negative root 2 over 2 and 1. So this is the range of g. Now asked to determine the values of x in the interval x is in elements of 0 degrees and 180 degrees, for which 1.3.1 for 2 marks, f of x times g of x is greater than 0. Now the number one mistake that most students make here, they try to take f of x and they substitute it here and multiply with g of x. You can do that, but it's quite pointless, because this is actually graph interpretation. So you must analyze the graph and answer the question. That's why it's only 2 marks. Okay, so how can we solve this? They are asking for the values of x for which when you multiply these two functions, you get a positive output, which is basically above 0. Okay, so what can we do from here? Well, let's look at this diagram over here. From here, which is 0, okay, we have 0 over here. At 0, the function f is over here. It's 0 and 0, and the function g at 0, it's negative, it's below 0. So what does that actually mean? What am I going with this point? I'm saying if you take this 0, and you multiply with this negative output, you're going to get 0. We are looking for the part which gives us a positive output. Now let's carry on. Let's move on to here. When we move along F and G, this one is positive, this part is negative. When you multiply a positive and a negative, what do you get? You get a negative. Now let's carry on. When you reach 45 degrees, we can see that there's 0 over here, and then over here this function is above 0 also, so it's positive, which means it's going to start from 45 degrees. So x should be greater than 45 degrees. And then when you move along, both of these functions are positive, positive, positive. They intersect over here, still positive, even though this one is now going down, this one is going up. They are both still above 0. Now when you get here at 90, these functions both are still giving us a positive output, so it should be below 90 degrees. Now when you carry on moving along the x-axis, you can see that this function is now becoming negative, this one is still positive. Now again, when you multiply a positive and a negative, you get a negative output. We are looking for x values that give us a positive output. So it's all values of x that are greater than 45 degrees and less than 90 degrees. So it's in this domain. X greater than 45 degrees, x less than 90 degrees. So this is your 2 marks, you are done. So we're now asked to determine the values of x in the interval x is in elements of 0 degrees and 180, for which 1.3.2 f of x plus 1 is less than or equals to 0 for 2 marks. So to make things simpler for us, let's just leave f of x on its own and then take positive 1 across. So it's going to be less than or equals to negative 1. So we are looking for the values of x which give us an output that is less than or equals to negative 1. When x is equal to 0, you can see that it's above negative 1. We're looking for an output which is below negative 1. So it's still above negative 1, still above negative 1, still above negative 1. You move along, you reach 105 degrees. At this point, it is now equals to negative 1. So you can then say x, okay, is greater than or equals to 105 degrees. So it means all the values of x that are greater than 105, they give us a negative, a negative, a negative, a negative. You move along somewhere here. There should be a point which is symmetric to 105 degrees. Now when looking at this function over here, we can see that 135 is actually in the middle. Now 105 degrees is 30 degrees to the left, which means a point that is a reflection of this one. It's basically 30 degrees to the right. This is 30 to the left, 30 degrees to the right. So 135 plus 30, you're supposed to get 165 and negative 1 over here. Now it's x less than or equals to 165 degrees. So it's all values of x that are greater than 105 degrees but less than 165 degrees that give you an output which is below negative 1. So 1.4 says another graph P is defined as P of x is equal to negative f of x, okay? Now D is a point K and negative 1. It lies on this graph P. Determine the values of K in the interval x is in elements of 0 degrees and 180 degrees. Okay, so we are told that P of x is equal to negative f of x. So P of x is equal to negative f of x. Now let's find the value of P of x. Negative f of x was 2 sine 2x, so it's 2 sine 2x. This is the value or the graph P of x. It's basically negative sine 2x. Now we are then asked to find this value of k. So how can we find the value of k? We have this y value of negative 1. k is our x value. Okay, so let's just simply substitute this point into this function. So y is -1 is equal to 2 sine, -2 sine 2x is k, so 2k. -1 divided by -2 is equal to sine 2k. 1 over 2 is equal to sine 2k. And then finally we're going to say shift sine of 1 over 2 is equal to 2k. You're supposed to get 30 degrees is equal to 2k divided by 2. 15 degrees is equal to k is equal to 15 degrees. Now remember, we're looking for the values of k. So we've got one where k is equal to 15 degrees. Okay, let me write that properly, sorry. K is equal to 15 degrees. Now let's now use a compound angle for 15. So it's supposed to be 90 minus 75. Okay, and then when you reduce this, you're supposed to get 75 degrees. So it's for k is equal to 15 and for k is equal to 75 degrees. So it says here graph H is obtained when translating G 45 degrees to the left. Determine the equation of H. Write your answer in its simplest form. Okay, so we are told that, or we are looking for the equation of h of x. That's what we are looking for. And we are told that this graph is obtained by shifting G 45 degrees to the left. And we're trying to find the equation. So h of x is equal to g of x plus 45 degrees. Simple as that. So h of x is equal to g of x is negative cos of x. Now what you should take into consideration is the words that they used. When they say to the left, it's actually the opposite. You should add 45 degrees. When they say to the left, you add. When they say to the right, you subtract. Okay? When they say to the left, you add. When they say to the right, you subtract. So this is going to be h of x is equal to negative cos of x plus 90 degrees. But we are not done, because they asked us to write this in its simplest form. So let's just write this in a way that we are familiar with. Negative cos of, this is the same as saying 90 plus x. Now we have h of x is equal to negative cos of 90 plus x. Okay, when looking at our cast diagram that we've been visiting quite a few times, it says 0, 90, 180, 270, and then back to 360. In the first quadrant, all trig ratios are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. In the fourth quadrant, only cos is positive. Now 90 plus x, you land in the second quadrant and only sine is positive there. We are given cos, so it's going to be h of x is equal to negative 1 times, the output is going to be negative, okay? And then remember 90 and 270, they change the trig ratio from cos to sine, so it's negative sine x, and then h of x is equal to negative 1 times negative sine x, that is simply sine x. So we have determined the equation of h.